In the present video, we will discuss the line balancing problem which is given in September 2020 from the JNTU Hyderabad. Let's see the problem. A manager wants to assign the task to workstations as efficiently as possible and achieve an hourly output of 33 1/3 units. Assume the shop works a 60-minute hour. Task times and precedence relationships are as follows. So in the following table, it is given the various tasks along with the its processing time and its immediate predecessor. Then question A, draw the precedence diagram. Question B, determine cycle time. Question C, determine minimum number of stations needed. Question D, assign task to workstations on the RPW method. Let's see the solution. So in the data, it is given the number of units are the 33 1/3 units and availability of the time is 60 minutes. So first question is draw the precedence diagram. For this, observe the given table. So in the table, you have to observe task A is having the no immediate predecessor. So it is the starting task. So first I have to draw the task A along with the processing time of 1.4. So next one is the task B. It will be start after completion of the task A. So now task A is completed immediately. Task B will be start and its processing time is the 0.5. So next is the task C, D and E. So these three tasks, it will be start after completion of the task B. So after completion of the task B, immediately task C, D, E will be start. So I have to draw the task C, D, E. So task C processing time is the 0.6 and task D processing time is the 0.7 and the task E processing time is the 0.8. So next one is the task F. It will be start after completion of the task C. So now C is completed, then immediately have to draw the task F along with its processing time is the 0.5. Next one is the task G. Task G predecessor task are the D and E. So after completion of the D and E, immediately task G will be start. So after completion of the D and E, immediately G will be start and its processing time is the 1.0. And next one is the task H. H will be start after completion of the F and G. So F and G start the task H and its processing time is the 0.5. So this is the precedence diagram for the given data. So next we have to look for the second question is determine cycle time. So we know that cycle time C equal to available time divided by number of units. So in the data it is given the availability time is the 60 minutes and number of units is the 33 1/3 which is equal to the 100 divided by 3. So number of units are given 100/3 and availability time is the 60 minutes. Then cycle time will become the 60 available time divided by 100/3. So which is equal to 180 divided by 100 which is the 1.8 minute. So cycle time is the 1.8 minute. Next we determine the minimum number of workstations. We know that number of workstation which is equal to the total task time divided by the cycle time. So we know the cycle time is the 1.8 minute and total task time will become the 1.4 plus 0.5 plus 0.6 plus 0.7 plus 0.8 plus 0.5 plus 1 plus 0.5 which is equal to the 6 and cycle time is the 1.8. So 6 divided by 1.8, which is equal to the 3.33. Then number of workstations are the 4 workstations. Next question is the assign task to workstations on the RPW method. In the RPW method, for the each work task, we have to determine the positional weight. And positional weight is the total time on the longest path from the beginning of the operation to the last operation of the network. So first I have to determine the positional weight of the task A. For this one I have to observe what are the possibility of the path. So from the starting task A to ending of the network, that is the H. So I have to observe what are the possibility of the path. Among the all the path I have to select the longest path. So for the task A, so this is the one of the path. So it will be, so start from the activity A to reach the ending of the network, that is the task H. So this is the one of the path, that is the A, B, E, G and H. In this path, positional weight is the 1.4 plus 0.5 plus 0.8 plus 1 plus 0.5, which is equal to the 4.2. Similarly, there is the another path also there, that is the A, B, D, G, H. In this path, positional weight is the 1.4 plus 0.5 plus 0.7 plus 1.0 plus 0.5. So in this path, positional weight is the 4.1. Similarly, another path also there, that is the A, B, C, F, H. In this path, positional weight is the 1.4 plus 0.5 plus 0.6 plus 0.5 plus 0.5. So in this path, positional weight is the 3.5. So among the all the path, longest path is the 4.2. Then positional weight of the task A is the 1.4 plus 0.5 plus 0.8 plus 1.0 plus 0.5, which is equal to the 4.2. So RPW value for the task A is the 4.2. So next we will determine the RPW value for the task B. So for the task B also there is the possibility of the path, or the three paths are there. First path is the B, E, G and H. In this path, positional weight is the 2.8, which is the 0.5 plus 0.8 plus 1 plus 0.5. Similarly, another possibility of the path is there, that is the B, D, G and H. So in this path, positional weight is the 0.5 plus 0.7 plus 1.0 plus 0.5, which is equal to the 2.7. Similarly, another possibility of the path is there, that is the BCFH. In this path, positional weight is the 0.5 plus 0.6 plus 0.5 plus 0.5, which is equal to the 2.1. Among the all the path, longest path is the, so path BDGH. So in this path, positional weight is the 2.8. Then positional weight of the task B is the 2.8. The path is the BDGH. So RPW value for the task B is the 2.8. So next we have to determine the positional weight of the task C. So for the task C, there is the only one possibility of the path, that is the CFH. So in the CFH, positional weight is the 0.6 plus 0.5 plus 0.5, that is the 1.6. So positional weight of the task C is 1.6 and RPW value is the 1.6. So next one is the task D. So for the task D, there is only one possibility of the path, that is the DGH, and its positional weight is the 2.2 and RPW value of the task D is the 2.2. So next I have to go for the next we determine the positional weight for the task E. For the task E, there is only one possibility of the path, that is the EGH. So in this path, positional weight is the 0.8 plus 1 plus 0.5, which is equal to the 2.3. So positional weight of the task E is the 2.3. So next we have to move to the determine the positional weight of the task F. So for the task F, path is the F to H. So in this path, positional weight is the 1.0. So positional weight of the F is 1.0. So next for the task G, for the task G also there is only one path, that is G to H, and its positional weight is the 1.5. And next one is the last task, that is the task H. So its positional weight is the 0.5. So this is the positional weight of the all the activities. Next, to rank the work elements in descending order of ranked positional weight. So based on the RPW value, we have to give the rank for the each task, beginning with the work element with the highest positional weight down to the one with the smallest positional weight. So we have to give the first rank for the highest positional weight, and next we have to give the second rank for the second highest RPW value. Like that we have to give the ranks for the all the task. So first I have to note down the RPW values for the each task. So for the task A 4.2, for the task B 2.8, and task C 1.6, and task D 2.2, task E 2.3, and task F 1.0, and task G 1.5, and task H it is the 0.5. So next, based on this RPW value, you have to give the rank. So here highest RPW value is the 4.2 among the all the values. So for the task A. So for the task A, you have to give the rank is the 1. And next to highest RPW value is the 2.8 for the task B. So next we have to give the rank 2 for the task B. And next to highest value is the 2.3 for the task E. So I have to give the rank 3 for the task E. And next to highest value is the 2.2 for the task D. So I have to give the rank 4 for the task D. And next to highest value is the 1.6. So for the task C. So for the task C, I have to give the rank 5. And next value is the highest one is the 1.5 for the task G. So for the task G, you have to give the rank 6. And next is the 1.0 for the task F. So I have to give the task F rank is the 7. And last one is the rank 8. So next we have to rearrange the task based on the its RPW rank. So I have to rearrange the table. So here first rank is the for the task A. So write down the first one is the first column is the task A, and processing time is 1.4, and immediate predecessor is the no, and RPW value is the 4.2, and rank is the 1. And next to rank is the 2 for the task B. So I have to next one is the task is the B, and its processing time is 0.5, and immediate predecessor is the A, and RPW value is the 2.8. And next rank for the 3 for the task E. So next we have to write down the task E, and its processing time is 0.8, and immediate predecessor is the B, and RPW value is the 2.3, and rank is the 3. And next to rank 4 for the task D. So write down the task D data, that is the So processing time is 0.7 and immediate predecessor is the B and RPW value is the 2.2 and rank is the 4. Next one is the rank 5 for the task C. Next I have to write down the task C and also have to write down the data also. Processing time is 0.6. Immediate predecessor is the B and RPW value is the 1.6 and rank is the 5. Next to rank 6 is for the task G. So after this C, task G will become, and write down its data also. Processing time is the 1 and immediate predecessor is the D and E and RPW value is the 1.5 and rank is the 6. And next rank is the 7 for the F. So its processing time is 0.5 and immediate predecessor is the C and RPW value is the 1 and rank is 7. And next one is the last one, rank 8 for the task H. So its data is the processing time 0.5 and immediate predecessor is the FG and RPW value is the 0.8, rank is the 8. Next, to assign the work element to a station. For this, choose the highest RPW element, then select the next one. Continue till cycle time is not violated. Follow the precedence constraints also. So next we have to assign the task to the workstations. Previously we determined the number of workstations are required are the 4 and cycle time is the 1.8. So next we have to assign these tasks to the respective stations. So for this one, draw the another rows. So first row is consisting of the cycle time. We know the cycle time is the 1.8 and next one is the workstation. So we have to start with the first task because first task, that is the A, which having the highest RPW element. So it is the highest RPW element and we have to consider the first workstation. So first we have to assign the task A in the station 1 and its processing time is the 1.4 and cycle time is the 1.8. After the assignment of the task A in the workstation 1, then ideal time will become the cycle time 1.8 minus processing time is 1.4. So ideal time is the 0.4. So next we have to move to the next highest RPW element, that is the task B. So for the task B, processing time is the 0.5 but here availability time is only 0.4. Then so in this regard we can't able to assign the work B in the workstation 1. So have to close the workstation 1 with the task of the A. Then we have to start the another workstation, that is the second workstation with the task B. So I have to start the second workstation. In the second workstation, first we have to assign the task B. Then its processing time is the 0.5 and cycle time is the 1.8. After assigning the task B in the second workstation, ideal time will become the 1.8 minus 0.5, it is the 1.3. So next we have to move to the next highest RPW task, that is the task E. So for the task E, processing time is 0.8 and availability time is 1.3. So we can be add the task E in the second workstation. Then after adding the task E in the second workstation, ideal time will become the 1.3 minus 0.8, it is the 0.5. So next we have to move to the task D and its processing time is the 0.7. But after allocation of the task B and E in the second workstation, ideal time or availability time is only 0.5. But processing time of the task D is 0.7. So in this regard, we can't able to add the task D in the second workstation. So I have to close the workstation 2 with the two tasks, that is the B and E. So next we have to start the third workstation with the task D. Its processing time is the 0.7. Then after assigning the task D in the third workstation, ideal time will become the 1.8 minus 0.7, which is the 1.1. So next we have to move to the next highest RPW task, that is the C. So for this one, processing time is the 0.6 and availability time in the third workstation after assigning the task D is 1.1. So we can be add the task C in the third workstation. Then after adding the task C in the third workstation, ideal time or availability time will become the 1.1 minus 0.6, that is the 0.5. So next we have to move to the next to task, that is the task G. So for the task G, processing time is 1.0, but availability time is only 0.5. So in this regard, we can't able to add the task G. If we close the task D and C with the workstation 3, then we have to start the next station, that is the fourth station, along with the GFH. But here, so total processing time for these three element is the 2, but remaining cycle time is only 1.8 only. We have the only workstation. In this regard, we can't able to add these three tasks in the fourth workstation. In this regard, we have to change the small modification in the table. So that is the, here I have to change the, so here we have to change the task F. Similarly, here also have to change the task the G. Similarly, have to change its processing time here 0.5 and here 1.0. And similarly here for the F process, immediate predecessor is the C, and for this one is the D and E. And similarly RPW value also have to change. Okay, now we have to see, observe here. For the task F, processing time is 0.5 and availability time in the third workstation after adding the D and C is the 0.5. So we can be add the task F in the third workstation. After that, its ideal time will become the 0. So now we have to close the workstation 3 with the 3 tasks, that is the DCF. So next we have to start the another workstation, that is the workstation 4. So with the task G, its processing time is the 1 and cycle time is the 1.8. Then ideal time will become the 1.8 minus 1, it is the 0.8. So next we have to move to the next task H. Its processing time is the 0.5. Then after adding the task H in the fourth workstation, ideal time is the 0.3. So this is the assignment of the task to the respected 4 stations. So in the first station, there is only one task, that is the task A. Its ideal time is the 0.4. And in the second workstation, there is the 2 tasks, that is the B and E. And its ideal time is the 0.5. So in the third workstation also there is the 3 tasks, that is the DCF. And its ideal time is the 0. And fourth workstation is with the task G and H, and its ideal time is the 0.3. So this is the solution, and thank you.